Welcome to the TechSwami podcast, where we talk about the decisions behind the software, not just code, tools, or frameworks, but the thinking that shapes systems as they grow. I'm your host, Vijay, and I've spent the better part of the last decade working with startups, building systems, tooling, frameworks, and more. If you're a founder, a senior engineer, or someone responsible for technical decisions, this podcast is for you. In each episode, I'll pick one idea that quietly makes or breaks scaling teams and unpack it from first principles using real trade-offs, real constraints, and real consequences. Let's get into today's topic. All right, let me start with a question. Have you ever joined a company or even just looked at a code base and thought, okay, how did we end up here? Not in a judgmental way, more like genuinely confused. Because on the surface, the team is smart, the product makes money, things are working. And yet, the system feels heavy, like hard to change, fragile in like weird places. I've been thinking about this a lot because we usually explain this by saying, yeah, the code is bad. But that explanation has never really satisfied me. Bad compared to what? Bad written by whom? And why does bad code, quote unquote, show up so predictably in growing teams? What I've seen over and over again is that scaling doesn't fail because engineers suddenly forget how to write clean code, although there are plenty of engineers that I know don't know the principles of clean code, but that's an episode for itself. It fails because decisions start to stack up on top of each other. One reasonable decision leads to another and then to another, and then you're 10 months down and you're trapped inside the consequences. That's how tech debt accumulates. So in this episode, I want to talk through that idea with you. Not as a lecture, more like, let's unpack this together. How one decision quietly shapes the next. How shortcuts don't just add debt, they change behavior. Here's the thing. Most of the time, the first bad decision isn't even technical. It's just about timing. Most startups don't fail to scale because of bad code. They fail because every decision they made makes the next decision worse. And that sounds dramatic, but if you worked on a system that's been alive for more than a couple of years, you know exactly what I'm talking about. People love blaming quote-unquote legacy code. They love saying, yeah, the code base is a mess. But code is just the artifact, really, if you think about it, right? The real problem is what led to that code existing in the first place. Let's start with a myth, I think, that almost every startup believes and almost always goes through as a rite of passage, I guess. We'll clean it up later myth. This sentence has probably caused more outages than any bug ever written. Here's the uncomfortable truth, right? Most bad code is written by good engineers. Not juniors, not incompetent teams, but thoughtful people. Why though? Because the first bad decision is almost never technical. It's temporal. It's optimizing for now. You have deadlines, customers waiting, revenue pressures, investors asking questions. So you hard code something because there's quote unquote only one customer. You'll skip migrations because we'll revisit the schema. You copy paste logic because this feature is similar. And in the moment, these are all reasonable decisions. They're actually very good ones when you're just starting out. The mistake isn't the shortcut, really. The mistake is pretending that shortcuts don't leave residue. They do. And that residue changes the future shape of your system. Here's my mental model that I want to share with you. Every decision narrows the option space for future decisions. That's it. That's the whole thing. One small choice creates assumptions. Those assumptions leak. They leak into APIs. They leak into schemas. They leak into workflows. They leak into how people think about the system. So let me try and make this a little concrete. You optimize a database schema for one query. Totally fair. That query matters today. Then an API is built around that shape. The front end depends on it. Analytics assumes it. a background job relies on it. Now, that schema isn't just a schema, it's a contract. And breaking that contract doesn't require changing code. It requires coordinating multiple teams, timelines, and having a tolerance for risk. So you don't change it, you work around it. That's what I mean by decisions pile up. These decisions compound. These are what called tech debt. Well, they're decision debt really, but they manifest as tech debt. So here's something engineers rarely like to admit out loud, at least from what I've seen. You know these if you've worked in tech for any amount of time. Those files nobody wants to open, the services everyone tiptoes around, the comments that say do not touch. Those areas don't get cleaned up, they get avoided. And avoidance changes behavior. New features don't integrate cleanly, they get bolted on. Logic doesn't get simplified, it gets extended. Patterns don't get questioned, they just get copied. So not because engineers don't care, but because touching those areas feels dangerous. So people optimize locally. Just add one more condition, just reuse this one function, just make it work. And this is where things turn ugly. Complexity increases, confidence drops, shortcuts increase. Shortcut increases lead to complexity spikes. That loop feeds itself. This is why I say code bases rot socially before they rot technically. Now, let's see how this affects scaling. Scaling doesn't create these problems, it merely exposes them. Load amplifies inefficiency. More users amplify edge cases. New hires amplify inconsistency. And when pressure hits, teams reach for fixes that feel powerful. Let's add caching, let's shard the database, let's split this into microservices. But here's the truth though. Scaling problems are rarely solved by adding infrastructure. Well, for obvious reasons, they do solve scaling problems, but the ones I'm talking about are not going to be solved by adding infrastructure. They are exposed by it. You add caching to mask bad read patterns, now you have consistency issues. You add background workers to handle load, now you have retries, idempotency bugs, and race conditions. You split services without clear boundaries. Oh gosh, this is the most common that I've seen. Now you have distributed complexity without distributed ownership. Every fix works, but only briefly. Then it creates new constraints. Then the next decision gets harder. So what actually helps then? Sure, we know all of these things exist, but what can you actually do about it? What's the real antidote here? Well, not perfect architecture. I don't think there really is such a thing as perfect architecture. It's all about trade-offs. It's not the right stack. It's not the language that you choose or the frameworks. It's really not rewriting everything. That's rarely the antidote. The real fix is designing for reversibility. Good architecture isn't about being right. It's about being easy to undo or even easy to change, actually. So that means making decisions reversible by default, documenting why something exists and not just what it does. This is where something like architecture decision records or ADRs are super helpful. Optimizing for change, not elegance, and delaying commitment, not progress. One of the things that I don't see teams use enough is feature flags. Feature flags can be used instead of branching logic everywhere. This at least forms explicit contracts instead of shared assumptions, and definitely use RFCs for decisions that are hard to reverse. You're not trying to predict the future, of course, I don't think anyone can, but you are trying to avoid trapping yourself. So, in closing, here's how I want you to reframe scaling failures. Your system isn't broken because the code is bad. Your system is a fossil record of your past decisions. Every shortcut, every assumption, every we'll clean it up later, they're still there. If you don't like what you see in your architecture, don't blame the code. Change how decisions are made. Change what gets written down. Change what gets questioned. Change what's allowed to be temporary. Because scaling doesn't fail at once, it fails slowly, one decision at a time. That's it for this episode of the Tech Swami podcast. I'll be unpacking ideas like this every week, how systems really fail, and how to design them to survive growth. Thanks for listening.